Hello, hi guys, good morning, welcome back to a new video. In this video problem, minimum operations to make median of array equal to k. Again, this is one of the worst problem statement we have seen recently in a contest in which the problem statement itself was not clear, and especially the confusing part was this example. We'll see, and we will see what the problem setter wanted us to understand without even telling. And also a big blunder that this question was solved by more than expected number of people, being a problem number 3. So people are just curious that why it is the case. We'll look for that in the end. But now coming on back, this again problem number 4 is already live. You can just see the comment section. But in this problem, you will simply see that you are given an integer array called as nums and a non-negative integer k. As you can see also, I have an array and I have an integer k. Now, in one operation, I can increase or decrease any element by 1. In this array, I can increase or decrease any element. So, no restrictions whatsoever. And one operation means one increase, one decrease. I have to return the minimum number of operations. I need to make the median of nums equal to k. Now, for the folks who don't know, median is something that if I sort an array, the thing which is coming in between or in the middle, that is called as a median. But Aryan, what if something is not possible to come at the middle? Which means if the length is even, then both the things which are coming at the middle, as you can see, it will be these two elements. I'll take the average of those two and that will result as a median for me. So this is the median for a length of even. This is the median for the length of odd. So they are saying that the median, I'm only concerned about, make sure I'm only concerned about the median. And I am saying the median itself should become equal to k. It should become equal to k. So they are just asking, and they just told also the median of an array is defined as the middle element of the array when it is sorted in the non-decreasing order. If there are two choices for the median, the larger of the two values is taken. They have added later on. Cool. Now, this is what they have mentioned now, and they have corrected that. But in the contest, people were just confused what is happening and what is median and all that stuff. But coming on back, now we are clear that what we will take. In this case, we will take this value. Okay. So, what and how can we solve it? Before going into that part, let's see if this would have been an array and I would have asked you what's a median, you'll have simply sorted this array. Sorting array will become as 2, 5, 5, 6, 8. Now, what's a median? Median is number 5. Now, I am saying this number 5 should ideally would have been 4, which is the value of k. Oh, okay, makes sense. Which means that you will end up reducing this 5 to 4. Okay, one operation done. Answer, let's say, is operation. One operation done. But Aryan, if you decrease this, it becomes 4. So I have to again sort it. Again, after sorting, it will become a 2, 4, 5, 6, 8. Again, this is the median. This again has to become a 4. Again, you will reduce this to a 4. Oh, again, earlier, my operation which I did was 1. Again, the operation which I will do will be 2. So now, after making this as a 4, you will see 2, 4, 4, 6, 8. Now this is sorted. So for sure, this will remain median as it is. So if you follow this strategy, what will happen? At every step, you will decrease and try to make it as a median. Then you will sort again. Then again decrease, then sort again. Again decrease, sort again. So decrease, you can decrease something. Okay, you will choose it. Maximum values which you can change in the entire array are n. So maybe n time you will try this decreasing pattern. Okay, but at every time you will sort it. So it will be n log n. So it will be n square log n, which will for sure not pass. What are we doing wrong? Or basically what are we missing? That's a major fact. You realize what happened when you decreased this. Although it was a median, when he was there at his place, he was the median. But when you decreased him, you still wanted him to be median. What in this world will make him still be median? Only and only when everything before him is small, everything after him is large. Only then he will be median. And that was actually what you were doing also. He went here, then 5 came here because 5 was large. So 5 came in median. Then you reduced him. So I'll say rather, you know that okay, 4 will remain here itself. You wanted him to remain here. even after sorting. How it will happen? Only when things before him should be reduced. Things after him should be increased. After him, I can see 6 and 8 are for sure more than 4. So no worries to increase. Before him, 5. 5 should be reduced. But if you remember, I want minimum number of operations. I have to reduce 5 so that everything before him should be less than or equal to 4. Again, in this order. Okay, in this order. Remember, it should be always increasing. It should be sorted. I have to decrease 5. I also want the minimum reduction, because every decrease or increase will incur me a cost. So I want minimum reduction, and I also want to decrease it. What I can do? Okay, bro. Simply, you want it to decrease. You want things to be less than 4, less than or equal to 4. So for sure, you want things to go at least to 4 and maybe below. I am at 5. So I'll reduce that 5 to 4. That is a cost which I have to for sure take. Although I will say, okay, I can still make this 5 to 3. That also will completely work. But reducing my 5 to 3 will incur a cost of 2. While reducing my 5 to 4 will incur a cost of 1. And I want minimum cost. So I will just reduce this 5 to 4. Again, 2 is already less than 4. So, okay, completely fine. And this 6 and 8 are already more than my 4. So this is what you realized, that I firstly sorted the array. Median I got, I have to bring that median to my value k. Okay, when I've got this median, now I have to make sure that this median stays as it is here itself. So everything after him should be more than equal to him. Everything below him, everything before him should be less than equal to him. And that is how I know that I am in the good direction, and I know I can simply get it. And I want minimum reduction. So I will make sure, okay, if something is high, I do as small reduction as possible to bring it to a expected value which I want. So this sorted, and this gave me answer of 2. One operation to reduce this and one to reduce this. Now let's look at this also for an explanation. So I will again firstly sort it, because I want median. So I'll sort it. 2, 5, 5, 6, 8. Median is 6, 8. Median is number 7. Median is number 7. So this should be replaced to number 7. Okay, I'll replace this with number 7. Cost incurred so far has been 2. 5 to 7. Cost incurred so far has been 2. Now expected number is 7, and which is here. Everything after him should be more than equal to him. Everything before him should be less than equal to him. When I checked before, I realized, okay, everything before him is in the order and less than. Again, remember the fact, it should be in the order itself. It is not like that. Okay, if you let's say it is reduced. Let's say it would have been 5 and it would have been 5 here itself. You reduce this to 4. So this 5 also would have to be reduced to 4, so as to make it in the decreasing fashion. Cool. So I realized that 5 is already less than 7 and 2 is already less than 5. So I'm good on the left side. On the right side, I should have things more than equal to 7. But I got 6. I have to increase 6. Increase 6, at least I should increase 6 to at least 7. I can go maybe 8 also. But I realized increasing every bit will incur me a cost. I want minimum cost. So I will increase as what is expected. Expected number is 7. I will increase only up till that amount. I'll increase only up till 7. So 6 to 7, increase cost will be 1. Okay. And you realize increase cost, like here the cost was 2. Here the cost will be 1. And after that, expected number is 7. Post this, everything should be more than 7. I have now 8. Okay, so 8 is already more than my 7. I am good to go. And thus, you will realize my cost incurred will be 3. Okay, last example, 1, 2, 3, 4, 5, 6. Now, you will see the length is even. So ideally, median would have been these two numbers. But they have told us that it will be the larger one, which is for sure nothing but n by 2th index. As you realize also, in these cases also, if I just name 0, 1, 2, 3, 4, n was 5. So the median is always n by 2 index. Here also length is 5, median is n by 2 index. Here also length is 6, median is still n by 2 index, which is 3. 0, 1, 2, 3, index is n by 2. So they have just explained this as a condition. Now, so we realize that this 4 should ideally equal to 4. And bro, it is already 4. 4 is already 4. So nothing required. And as you can see, answer is 0. So that is what you had to do ultimately. If we look at the code, it will simply firstly have to sort it. If it is not sorted already, we'll sort it. And then again, even if it is odd length or even length, I realize that my median will for sure be indexed at n by 2. So even if it, again, this if condition is not at all required, but it's just for you to make sure that you know what is being done here. Even if the length is n by 2, or the length, sorry, even if the length is even or odd, in any way whatsoever, your median will be n by 2. Your middle element will be n by 2 at index n by 2. Now, you know your expectation right now is k. Your expectation is k. So I will make sure, okay, my expectation is k. So for sure, the middle element should be equal to k, exactly equal to k. So I'll say, okay, whatsoever is the middle element, maybe high, maybe low, it should be exactly equal to expected value, which is k. If not, then bring it up. And if I bring it up, so for sure the difference whatsoever will be there. I have to add that as a cost in my answer. Now, middle element has gone to expected value, but the other ones on the left should be less in this order, and on the right should be in the increasing order. So I'll go in the left first. That, okay, should be in the decreasing order. So I'll just say, okay, as you can see, let's say this is the middle element. This is the middle element. Now I'm going on in this order itself, and I want it to be decreasing. This is the right now expected value. So I mentioned, okay, if expected value, if nums of I is already less than the expected value, so for sure I will say expected value has now become my nums of I itself. Okay, again, you can take minimum, but you can easily see that expected value will be nums of I itself, and you can simply continue. No cost added. Nums of I was already less than expected, what I wanted. But if your nums of I is more than expected, which means as you realized, if the expected is 4, but nums of I is 5, nums of I is 5, expected is 4, it is more. If something is more, bro, bring it down and bring it minimum down. So I'll bring this nums of I to expected itself, which is 4. So I'll bring my nums of I to expected itself, which is 4, and that is a cost which I will have to add in my answer. And the same way I will go on if I go on the right side, which means I'll go from mid plus 1 to up till n. If nums of I is more than my expected, okay, simply move on, bro. Continue. You can simply move on. Again, make sure that you can do it or not do it. It's up to you. That it is at the moment what I thought of, but as you can simply see, expected value will again be nums of I itself. That's totally up to you. And you can also break here itself, because everything will be sorted already in the right side. But if not, if your expected value is less and you are going on the right side, expected value here, it is more, and in nums of I value is less. You want to increase, it is nums of I is less expected. So bro, bring it up. So what you will do, you will bring it up. You will bring your nums of I up. So expected is there, nums of I is there. You will bring your nums of I up to expected, and thus you will have to add that specific cost, and ultimately this will be the cost which you have to add in your answer. Now, it seems like greedy, but you realize that you have proved it, that why it is correct, because ultimately at every step, even if you would have sorted it, you would have bought that bigger number on the middle itself, and then you would have again decreased it. So why not decrease them while going backward and forward itself? Cool. Now, coming on back to a point that why many people submitted. Yeah, see, there can be a chance. Again, I'm not saying I know who is cheating and who is not cheating. There can be a chance people are cheating, but we don't have to focus on that. We just have to focus that, okay, were we able to solve it? Because it's an ad hoc problem, as you must have thought of. It's an ad hoc problem. So it doesn't require any knowledge of data structures. It's just simple sort, which we can for sure do. So it is more of ad hoc problems, which we should be good at, right? Usually you see less problems on Leetcode which are ad hoc, but this we should be knowing. Goodbye, take care. And yeah, again, don't worry about others. They will cheat. They will stay ahead. Like they will stay behind, sorry. Bye-bye. Cool.